Hey everyone. In the last video, we went over one of the most important foundations for machine learning, which is linear algebra. In this video, we're going to be going over the next one, which is calculus. So let's get into it. Calculus is all about measuring change. So in this video, we're going to be talking about four topics: slope, derivative, minimizing a cost function, and the commonly used symbols. Okay, so let's say I have an ice cream shop and I'm selling ice creams on a daily basis. And I want to know how temperature affects my shop's ice cream sales. So intuitively, we know that as it gets hotter, there are probably going to be more ice cream sales. So as temperature increases, ice cream sales will also increase. So we have the following graph with temperature on the x-axis and ice cream sales on the y-axis. And you can see that as temperature increases, ice cream sales also increase. But what if we want to measure how strong this increase is? So if we increase temperature by 1 Celsius, how much does our ice cream sales increase? Does it increase by 10? Does it increase by 20, 30? Well, to calculate this, we use the slope. And the slope can be calculated by using the rise over run formula. So in this graph, we can see that a change in temperature of 5 results in a change in sales of 10. In other words, every time we increase temperature by 5 degrees, it increases ice cream sales by 10 degrees, by 10 sales. So to calculate the slope, we just take the rise over run. So the rise is the change in y, and the run is the change in x. So 10 divided by 5 is 2. What does this tell us? Well, it tells us that for every 1 degree increase in temperature, ice cream sales increases by 2. And that's the strength of that relationship. Now, let's say if the slope was 3, what would that mean? Well, that would mean that for every 1 degree Celsius increase in temperature, ice cream sales would increase by 3. And that would also correspond to a steeper slope. Changing a variable, example temperature, will often change another variable, example number of ice cream sales. Slope measures the strength of this change. Another word for slope is gradient. They mean exactly the same thing. Okay, let's talk about the derivative. Whereas for a straight line, the slope is constant throughout the graph. For curved functions, the slope is changing. So in this straight function, in this straight graph, the slope is the same no matter where you are on the graph. But for a curved function, such as this one in blue, the slope is actually changing throughout the graph. So you can see here at the bottom, the slope is flat, so the slope is 0. However, here, the slope is 8. And here, the slope is actually negative. It's negative 6. So that's the difference between the derivative and the slope. The slope is for straight line functions, whereas the derivative is for curved functions, where the slope is changing throughout the graph. For the above plot, the function graphed in blue is f of x equals x squared. The derivative of this function happens to be 2x. Now, how do we calculate this derivative? That's another topic. And I actually have a series on my YouTube channel where I go into more detail how to calculate derivatives and how to compute the derivatives. So if you want to learn more about that, please go check that out. But in this case, the derivative of f of x equals x squared happens to be 2x. What does this mean? Well, it means that we can calculate the slope of f of x for any value of x. So the slope at x equals 0 would be 2 times 0, which is 0. The slope at x equals 4 would be 2 times 4, which is 8. And the slope at x equals minus 3 would be minus 6. In a nutshell, the derivative tells you the slope at any point in time. So for any value of x, we can calculate the slope at that point in time, at that value of x. So if we have a value of x minus 2, we can calculate the slope. And it depends on the function as well. So for a different function, we'll have a different derivative function as well. Now let's talk about minimizing a cost function. So, arguably, one of the most important applications of calculus in machine learning is minimizing the cost function, or you might also hear it as the backpropagation algorithm. Now, it sounds kind of complicated, but it's really a straightforward concept. So let's dive into it. When we want to minimize a function, we want to find the lowest point of that function, which is called the minimum point. We are usually given a starting point, and we want to iteratively approach the minimum point. Now, looking at this graph, we can obviously tell the minimum point is at x equals 0. But in the scenario where we're training a model, a deep learning model, we don't actually know what this function looks like. So we need a strategy, a method to arrive at the minimum given some arbitrary starting point. So in this example, if we start here at the green circle, how can we use what we know about the derivative to iteratively get to the minimum point? So, given a function and a starting point, we can use the derivative of the function to gradually approach the minimum point. And here are the steps to do that. If the derivative is positive, jump left. If the derivative is negative, jump right. And you repeat this until the minimum is reached. So let's say we start here on the right side. Now, if we calculate the derivative, it's not so much important what the actual number of the derivative is. What's more important is the sign. So in this case, the derivative would be positive because on this side of the graph, as x increases, y also increases. So the slope would be positive. Now, knowing that the slope is positive and that if we increase x, we want to increase, it will increase y, how would we get to the minimum point, which would be at the lowest x, at the lowest y? Well, we would want to decrease x, right? So what we do is we jump left. So starting here, we jump to the left side. Again, now we calculate the derivative. In this case, the derivative would be a negative number, which means if we increase x, y will decrease. And that's exactly what we want, right? We want to approach the point where y is minimal. So we jump right. We increase x. So we jump right. And then we keep doing that until we reach the minimum point. And that's how we minimize a function. Now you might be asking, what's a cost function? Well, a cost function simply tells us how bad a machine learning algorithm is performing. A good ML algorithm will produce a low cost, while a bad ML algorithm will produce a high cost. So it makes sense that minimizing the cost function will help us find a good machine learning algorithm. Another term that's often thrown around in this context is optimization. In simple terms, when someone says they are optimizing an ML algorithm, it just means that they are minimizing the cost function. In calculus, there are some commonly used symbols, and it can be a little bit confusing when you see these symbols in the literature, but most of these symbols mean very similar things, and I just want to provide a brief overview of what these symbols mean. This symbol here is referred to as dy dx, and it just means the derivative of y with respect to x. For example, the derivative of ice cream sales with respect to temperature. This second symbol is also the derivative, but it's called a partial derivative. So it's for something called multivariable functions, which is just a function with multiple inputs. And you can treat this as the same thing as dy dx. But if you want to say it, and you want to, you might hear it being said as partial y partial x. But again, it's the same thing as the derivative. And this final symbol is called nabla, but again, it just means the gradient or the derivative. So all these three symbols just mean the rate of change of one variable to another. Now, while these symbols do have their own nuanced meaning, they do differ slightly in their meaning, they still convey the same concept, which is just that rate of change. Cool. That's it for calculus, and again, I'll put the link in the description for the article in the description box below. And if you want to learn more, in the article I've also added these links. These are resources I found very valuable for learning calculus, and I use these resources a lot. So that's it for calculus. In the next video, we'll be going over the final pillar of the maths behind machine learning, which is statistics. So look forward to seeing you then. If you like the video, send us a like, and don't forget to subscribe to the channel so that you are updated when new videos come out. Thank you so much for watching, and I'll see you in the next one. Peace.